Hi there. We talked today in class about geometric sequences and how to build them in recursive formulas and explicit formulas. This particular problem is number 2 on your 5.6 practice worksheet. And in number 2, we are asked to determine whether the sequence is a geometric sequence and to explain why. And if the sequence is a geometric sequence, I should be able to look and see, am I multiplying 108 by some number to get 36? And is 36 times that same number 12? And is 12 times that same number 4? And if I can find that common ratio, then I know it's a geometric sequence. Now looking at 108 to 36, there isn't something that's immediately jumping out at me. 108 times 2 isn't 36, right? There's not going to be that immediate multiplier. And so I'm going to use the inverse operation to help me find it. 108 times that number should give me 36. So 36 divided by 108 should give me that number, inverse operations. And so that's what I'm going to do here. I'm going to do 36 divided by 108. And I get 1/3. And so I know that 108 times 1/3 gives me 36. In fact, I can check that really quickly just to double check. And I get, sure enough, 108 times 1/3 is 36. And so then I'm hoping that 36 times 1/3 will give me 12. So let's find out. As I do 36 times 1/3, I get 12. And as I do 12 times 1/3, I get 4. And so sure enough, I have found my common ratio, which means that yes, this is a geometric sequence, because between each term I am multiplying by 1/3. And there's my answer. Hi there. We talked today in class about geometric sequences and how to build them in a recursive formula and an explicit formula. So looking at number 20 on your 5.6 practice worksheet, we are asked to determine if the sequence is a geometric sequence, and if it is, to find the common ratio and write the explicit and recursive formulas. So there are several steps to this problem. The first is to determine if it's a geometric sequence, and the only way this is a geometric sequence is if, as I look from -8 to 16, and 16 to -32, and -32 to 64, the only way it's a geometric sequence is if I'm multiplying by the same number each time. So looking at -8 to 16, the multiply might jump right out at you. If it doesn't, we can find it using inverse operations. We can do the 16 divided by -8, and we get -2. So I know I'm timesing by -2. -32 divided by 16, I get -2 again. And when I do 64 divided by -32, I'll get -2 again. And so that proves that it's a geometric sequence because -2 is my common ratio, and we're going to go ahead and call that R. My common ratio is -2. So to build a recursive formula and an explicit formula, our recursive, our first term is that -8, right? The first term in the sequence. And so then our recursive formula is a of n equals a of n minus 1 times my r. And my r in this case is -2. My explicit formula is a of n equals a of 1, which is my first term, so -8, times my r, which is -2, to the n minus 1. And that's my answer.